I'm Greg Miller.
I'm Justin Eckstein.
And I'm Derek Coleman. And this is our senior design project at the University of Nebraska-Lincoln. And the goal of our project is to make a tracking device for pheasants.
Alright, so the motivation behind our senior design project is we wanted to learn the lifestyle and movement habits of pheasants. Current devices are either too expensive, too large, or they don't give GPS fixes, for instance, VHF transmitters.
So the goal of this project is to create a tracking device that is lightweight, less than 30 grams, which is 3% of the body weight of a pheasant. And it also needs to be able to recharge off of a battery. We have a solar panel, and we need to be able to collect the GPS fixes and wirelessly communicate those over to a base station.
So this is our third iteration board. Over here is the low frequency antenna. This operates at 433 megahertz. And then over here is the GPS device, and it gives us the feeds over, it gives us the NEMA messages as we listen to it over UART. And up here is the JTAG header. And then over here is where we connect both the battery and the solar panel to the board. And then over here is the on and off switch. Now, this board had several problems that we had to discover and figure out. And one of them was this JTAG header, this pin right here that doesn't have a wire sticking out of it. That was supposed to be unconnected, so we simply just had to take it out to avoid running into problems with the programmer. And then another thing was we removed some power circuitry devices trying to get the part count to be lower, and in the process of that we accidentally disconnected two nets that were supposed to be connected together. So once we figured it out, we simply just had to solder a wire from the 2 points to complete the connection, and then after that the device started working again. So that's the third iteration and all the things we've learned from toying with it. Hello. So right now I'm working on trying to fix this board because there's some hardware issues with it. So what we're gonna have to do is manually solder in a wire to make a connection between two different nets that are currently unconnected. So we're basically going to be making a connection from one of the pins here to a pin down here. Here's the board with the wire we attached to fix the missing connection problem that we had. And now we're going to hook it up to this power source to see if the nets that we were looking for earlier now have a voltage, because they should. Power supply over here has a voltage of 3.3, and I think you could see that. And then the multimeter over here is going to give us the voltage, and this pin should now be at 3. If I could make the connection. And it is at 3.267, like we want. Hello. So now we're here to test one of our boards. We already did the fix to fix the unconnected power net. And now we're going to hook up the UART. We're going to connect to the UART with a USB bulb. We already have the power and the JTAG hooked up. So now we just need to make this test program, which all it does is print hello count and this value of this integer, which it keeps incrementing. So we program it. Still programming. And then we run this. We connect to the UART. We connect to the hub over UART, and as you can see, the hello count is being sent from our device. So the device works. And that's our demo.
Then we zoom in on the Pheasant.
Hello. So it's Justin and I, and we currently have our device set up, running, and it is now with the GPS receiver right here, and we have the device running, and as you can see now, it's actually pulling current because the GPS requires a lot more current than the MCU. And it's running a simple program where it's receiving the GPS fixes from the GPS over UART, and the MCU is then relaying the messages over a different UART, which we are listening to via this USB bub. So when we look at the computer over here, you can see all the GPS messages. And because we are inside, we literally cannot see any satellites. But when we go outside, that would change.
Alright, so we're out here field testing, and if you take a look over here, you can see that we have two motes. We've got our base station, and we've got our other mote. So this one's going to be sending out beacon messages, and once it gets a reply from this one will send a GPS fix back that we can use to collect data with, and we'll use that to figure out exactly what our range is. So next up, we're going to actually show some video of us doing a field test here along this grass.
Alright, so I'm back here with Justin at the base station, and our partner in crime, Greg, is out there with our mote, and we are testing the range. And you can see him way wildly, and if I get a good shot, you can see the device in his hand. And this is how we are testing the range of the device. And Justin's at his computer analyzing the data we're getting back. Alright, so this is our device on how we imagine it would go on a pheasant. The solar panel goes on top, and it's basically a collar device. And evaluating our design, it is slightly too big, but that's because we broke out a lot of the pins just to debug the board, and it's 6 grams overweight. Our target goal was 30 grams, but our device with the battery weighs 36 grams. Although the board itself only weighs 16 grams, 20 of the grams, most of the weight of the device is in the battery, which is that thing.
So in the end, we did get a working device. It's able to wirelessly communicate with the base station and collect GPS fixes. There are a couple of shortfalls that we came across. One would be the weight of the device, and also the range of the device. The weight of the device ended up being just a little bit overweight, but we believe we can bring that down if we delete some of the extra pins that we had on there for testing purposes. And then the range of the device ended up being at about 70 meters when we were testing. We were looking for it to be about 1 kilometer, but we believe that if we work with the impedance matching on the antenna, that we should be able to increase that range.